right, so let's continue where we left off at. Lesson 3.6 on solving radical equations. Now we're also going to take a look at some rational exponents. So example 3 has us solving an equation with a rational exponent. But again, same thing we want to do is we eventually want to get this isolated by itself. So step 1, get rid of that 2. So now I have x minus 1 raised to the 2/3 equal to 4. Now I want to get rid of that 2/3, so the best way is to figure out a way to make the exponent equal to 1. So let me multiply that by 3/2. Just like I would if I had a fraction for my coefficient, I would multiply by the reciprocal. If I have an exponent, a fraction for my exponent, I'm going to multiply, or not really multiply, but I'm going to raise it to the reciprocal of that exponent. And of course, do that to both sides. Now that will make the exponent here equal to 1, so that gives me x minus 1. And then I have to take 4 to the 3rd power, and then take the square root of that, which would give us 8. 4 to the 3rd power is 64, and the square root of 64 is 8. Of course, you can also use a calculator. Simplify these baby steps. Add 1 to both sides, and x is equal to 9. So take a look at our calculator. Let's plug in our solution to make sure it is true. Does 9 minus 1 raised to the 2/3 plus 2 equal 6? And we're checking our solution. That's what we're looking for. So 8 to the 2/3 plus 2, does that equal 6? Well, 8 squared is 64. The cube root of 64 is 4, since that comes from 4 times 4 times 4. And 4 plus 2 is equal to 6. We know that our solution is correct. All right, but I did warn you that the questions were going to get a little more complicated. So let's take a look at what happens when we have radicals on both sides of the equation. We already know that in order to get rid of a radical sign, we have to take the square of it, or if it was a cube root, we take the cube of it. So we're going to do the same thing. We're going to go ahead and square both sides of our function. Now, of course, that gives us x plus 1 on the left-hand side, but we've got to be careful of what that's going to do for us on the right-hand side. So I'm going to bring this out and show you step by step. Here lately, for some reason, students have started taking this little exponent out here and trying to distribute it to the inside. But that is not what it means. It means the whole thing multiplied by the whole thing. And then you have to use FOIL to go ahead and multiply it out. So we have square root of 3x times the square root of 3x, which would of course give us just 3x. Then we have negative 1 times the square root of 3x. I'm going to just go ahead and just put minus square root of 3x. And then inside, so we did first outside, now inside. And last. Go ahead and consolidate that, bring that into 2 steps. And that's what the square root of 3x minus 1 squared is equal to. Please do not say that this is 3x minus 1 or some other weird distribution. Alright, so let's bring this all together. So 3x minus 2 times the square root of 3x plus 1. Alright, I want to go ahead and get all of my non-radicals to one side. So I'm going to subtract 3x from this side. That's going to give me negative 2x. And I'm going to subtract 1 from this side, which will then, of course, cancel that out. So now I'm left with negative 2 times the square root of 3x. Now let's go ahead and divide by that coefficient of negative 2. And I'm left with x is equal to the square root of 3x. So I still have that radical sign, but now it's only on one side. So I can go ahead and square this, square the left-hand side, and now I'm left with x squared is equal to 3x. Now remember, when we're solving quadratics, we want to put all of our x's onto one side. So rewrite this to say x squared minus 3x is equal to 0. This square tells me I possibly have more than one solution. Go ahead and factor this. And we can see that x would be equal to 0 or 3. Now, it's very tempting to go ahead and say those are your answers and you're done, go ahead, good to go. But we need to actually check for extraneous solutions. Check for solutions that when we plug them in, don't actually equal the answer we want them to. So these are just possibilities at this time. So I'm going to copy this, I'm going to erase this, and we're going to check for our solutions. So make sure you have your work copied down. If not, pause it for a second, because I'm erasing it. All right, so we said that x could be equal to 0 or 3, so we want to check it. So let's check for x equaling 0. So plug it in. Does 0 plus 1 equal the square root of 3 times 0 minus 1? All right, so the square root of 1 is equal to 1 on the left-hand side. The square root of 3 times 0 would be 0. 0 minus 1 would be negative 1. Those are not the same. Remember, we assume we want the positive unless there's a negative in front. Since there's no negative in front, we want the positive. 1 is not the same thing as negative 1, so x equaling 0 is not a solution. All right, let's check to see if 3 is a solution. So 3 plus 1, is that equal to 3 times 3 minus 1? So 3 plus 1 is 4. Square root of that would be positive 2. On the right-hand side, obviously square root of 3 times 3 would be 3, since you have a pair of 3's. You don't even have to multiply that to make it 9. 3 minus 1 is 2. These are equal, so x equaling 3 is our solution. X equaling 0 is extraneous. Weird word, but it just means it's extra, it's not necessary, and it's not correct. So when you are solving your radical equations and you get multiple possibilities for x, you have to check to see if any of them are considered extraneous. They might both work, they might both not work, all right? You've got to double check them. They're off the board, and let's take a look at the last practice problems of chapter 3. I just had a mental image of all of you celebrating that. So here are your 3 practice problems. Solve the equation, make sure you work your order of operations. Be very careful, oops, yeah, very careful in more ways than one. Be very careful with these type of problems that have the radicals and similar things. Take it step by step, please go slowly, make sure you are multiplying correctly, make sure you're foiling correctly, make sure you're doing all of those steps that are correct. Pause as long as necessary for you to check your answer, and when you are ready, please feel free to move on to the solutions. All right, so here are the answers to the 3 questions, and when you are ready, circle whichever ones you have problems about, we will discuss it in class.